Good morning. Today we are continuing on the Co11. I can simplify expressions by squaring and using square roots. Now, our objective before, we saw there were a couple of problems with those squaring, with the base, with the exponent of 2, and I kind of talked about that a little bit, how that works. Now we have the objective that's really going to make us practice it to make sure we understand it completely. So if we weren't sure on yesterday's objective, there's some exponents and I wasn't sure what to do, we're going to be really working on that today. So, time to dissect that PERMDAS, specifically the E and the R. Okay, so it's not PEMDAS, it's PERMDAS. Last year you didn't work a lot with exponents and radicals, so we're going to do it today. Complete the table below to help you remember your perfect squares. So last year, I had turned 49 for my birthday, and Gianna had turned 16 for her birthday, and Rosa was super excited because she's my math girl, and she's like, oh, you and Gianna are both perfect squares this year. So we had a year of being perfect squares together. What does it mean to be a perfect square? LJ? The number multiplied by itself gives you that number. So what was I a perfect square of if I had been 49? 7. What was Gianna a perfect square of? Tessa? 4. Because 4 times 4 is 16, 7 times 7 is 49. So we had our year of perfect squares. Unfortunately, I'm not a perfect square again, but that's okay. But let's look at those exponents. Let's look at those perfect squares. If we are 1 squared, that means 1 times 1. What is 1 squared? Everybody? 1. What would 2 squared be? Everyone? 4. Because 2 times 2 is 4. What is 3 squared? 9. 9. Because 3 times 3 is 9. We have to get ourselves a way of thinking it's 3 times the 2. That's not what that exponent means. That means how many times are we multiplying that number by itself? What would 4 squared be?
16.
5 squared?
25.
6 squared?
26.
7 squared?
49.
8 squared?
64.
9 squared?
81.
10 squared?
100.
11 squared? Good. 12 squared?
144.
Good. 13 squared? Not quite. Got all those multiples of the 3 in it. 169. 14 squared? 196. 15 squared? You're pulling up that calculator, Robbie. 225. And 16 squared is 256. Now, you are going to want to know these perfect squares because they pop up all the time in math. All the time. As we work on math packets throughout the year, we'll be looking at that pattern page, where we have the different blocks and figures and what's the pattern. A lot of times that pattern is going to have to deal with perfect squares. They are my favorite kind of numbers. I don't know. Just call me a mathy person. I love perfect squares. So I'm always looking, when I'm looking for patterns, to see if perfect squares are popping up. Now my radicals, those square roots, remember, is the opposite of the exponent. So if my square roots look like this, square root of 1 would be what? What times itself equals 1? Vivi? 1. So my square root of 4. What times itself equals 4, Amala? 2. Square root of 9. Luke? 3. Notice this pattern. If we look straight above, 3 squared is 9. The square root of 9 is 3. Okay, so what would be under my next square root? Eleanor?
16.
And the square root of 16 would be what,
4.
Eleanor?
4.
4. Okay, so we take that perfect square, we put it under the square root, and its answer will be the number that we multiplied by it to get to it. So I'm going to take the 25, square root of 25. Everybody, what is it?
5.
Square root of 36.
6.
Square root of 49.
7.
Square root of 64.
3.
Square root of 81.
9.
Square root of 100. 10. Square root of 121.
11.
Square root of 144.
12.
Square root of 169.
20.
Square root of 196. Square root of 225. Square root of 256. Notice how they are the opposites. Just like 2 times 5 equals 10, 10 divided by 5 equals 2. Those are multiplying and dividing are opposites. 2 plus 3 equals 5, 5 minus 3 equals 2. Adding and subtracting are those opposites. Exponents and radicals are the opposites. Remember not to multiply the exponent by the base. So if we look at that, 3, the big number is the base. Your exponent is that little number. That is not 3 times 2. It is 3 times 3. Because there's a 2 there. We're multiplying that 3 by itself. So we see the 2 3s. So going with that logic, what would 2 to the 4th power look like? That would be 2 times 2 times 2 times 2. Because there's a 4 as my exponent. So I would multiply by 2 4 times. So I would say 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. I didn't say 2 times 4 equals 8. When we're working with those exponents, you take that base number, the big number, the exponent tells us how many times we're multiplying the base number. Does that make sense? Most of us are saying, yeah, that makes sense. Some of us are saying, I'm not quite there yet. On this page, we are just working with the squares and the square roots. Perfect squares with their square root. So we don't have to quite be to this point yet, but I'm exposing us to it. Okay? So just know that it's not 3 times 2. It's 3 times 3. So let me scroll up so we can see what we're doing. Yes?
When it's doing the, are we going to talk more about to the power of 4? Because, it's confusing me a bit.
Looking ahead, I'm not sure when that comes up. Not today.
Like, when I say power of 4, I mean the exponent of 4.
I know power of 1 is something. I've been using that same phrase. Okay, so let's look at today when we're just working. Oh, wait, I see down here. Look, Eleanor. Down here we are going to work with it.
The bigger numbers?
So we are working with it more today.
Okay.
Okay, so let's start up here where we're just squaring. We're multiplying it just twice. that base number. So, use the tables above and the order of operations. So that first row is going to be easy. You're just using the table, right? 8 squared. We need to evaluate what is 8 squared. Adley, 64. So that's an easy one. We have square root of 49. Claire? 7. Okay, that's all you have to do for that first row. Just look at the table. The second row, we have to use the order of operations. Remember, PERMDAS. So you have to follow the order of operations. So if we look at 7 squared minus 16, minus the square root of 16, what's the first thing I'm going to do? Bobby?
Like get them into actual numbers.
Okay, so I have to follow PERMDAS, right? So I've got my PERMDAS, there's no parentheses. My next layer is that exponents and radicals. Reading from left to right, I see both exponents and radicals in this expression. I read from left to right, so I'm going to say, what is 7 squared? Go ahead and say it out loud. And I see I have a square root. What is the square root of 16? 4. Now I'm going to bring down the rest of the expression. I have a minus in there. So I did my exponents and radicals, reading left to right. I don't have any multiplying or dividing, so I don't have to do that level. Now I'm at adding or subtracting. 49 minus 4 is 45. How are we feeling about that?
Good.
All right. Now, Eleanor pointed out that we have a tricky one. It's not just squaring. We have different exponents going to the different powers. So what I was showing us up above with 2 to the 4th power is 2 times 2 times 2 times 2. We look down here, we have 3 to the 4th power. What is the math that I'm going to do to figure out what 3 to the 4th power is? Hadley? Yeah, 3 times 3 times 3 times 3. Now, the beauty of being in Big Kid Math is we don't always have to do all of that kind of math going out. We have our fancy schmancy calculators. So let me show you how we do 3 to the 4th power on our calculator. Okay, so we turn our calculator on. If we want to just square a number, we would say, let's say it's 3 squared. We would do 3, and then you see that x to the 2nd power, x squared. You just press that, and then you hit equals. You can see the base of 3 with the exponent of 2, and you hit equals. That's how we square a number with the calculator. We know that table goes up to, did it go up to 16? But you might have to square 200 or 22. One that's not easy to do in your head, you would use the calculator for it. Now, if we have a number, like 3 to the 4th power, using the calculator, you put in your base first, that 3, and then our little, we call it a caret, that little arrow button that's above the square button. So it's got that arrow on it. You press that. Then you press what your exponent is. So 3 to the 4th power. So you see 3 with the little caret, that little arrow to the 4th power. You hit equals, and it tells you what 3 to the 4th power is. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So you can use the calculator to do those big exponents, but on the test, we're not using our calculators. No. So this is how you check your work on today's assignment. You're not going to be getting 15 to the fourth power. You're not going to, on the test, you're not going to get big exponents that you have to multiply out. You're going to get smaller ones, 2 to the third power. You can do 2 times 2 times 2, right? That's easy math. You're not going to get the complicated hard ones. That's coming later in pre-algebra. All right? I'm showing you how to do it now so you can check your work. So on your math binder, you would want to do the math. You would want to know that 1 to the 8th power is 1 times 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5, 6, 7, 8. What is 1 times 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 1? What would it be, Tessa? 1. That's an easy one. All right, 1 to any exponent is going to be 1. So then we need to know that 3 to the fourth power is 3 times 3 times 3 times 3. So you're going to do that math. We did it together and we said 81. And then we have the square root of 64. Second, 8. Then we bring down the rest of our expression and we continue following that order of operations. On the bottom it says using an exponent in one and a radical in the other, write 2 expressions that equal the page number. What is our page number? 23. Okay, so you have to write 2 expressions on the bottom. Do not forget to write your 2 expressions on the bottom. One using an exponent, one using a square root. You can use other operations to get to it. Okay, 5 squared. I might want to subtract something from it. Okay, get creative. Natalie.
What about the fraction?
So where we would do the square root, that's a great question. You would do the square root of 36 over the square root of 125. And then simplify your fractions. Okay?
Okay.
David?
Are there any, you have to do any, like, certain number of, like on the last week, you have to do
It doesn't have a limit of operations. We don't want to overcomplicate, because if we overcomplicate, that's when we make mistakes. So keep it simple, but you're not just going to square or just do a square root, because 23 isn't a perfect square. So you're going to have to add or subtract or do something more to it. Any other questions? All right, so you're going to quietly work, making sure you're doing your order of operations correctly. So really look and think, am I doing this correctly? If you are watching this at home, I hope you're well. I hope to see you soon. Don't forget to like and subscribe. Have a wonderful day.